with AI. This is a simple test-driven development example. It's all about units converting. And what we're going to do is program up a temperature converter. It's a very simple problem, but it's an example of how we might do coding with AI. So there is a GitHub repository that is available on my personal Ruthless Help GitHub, and the units converter main branch is there, and you can download the zip for a local copy if you want to go along with this. The README provides instructions on how to create, activate, and get started. It goes through installing PyTest. So I've already gone through to the point where I've installed PyTest, which is going to be our testing framework in our test-driven development. And so at this point, I have installed PyTest and done all the other steps above this. And now I have PyTest version 8.4.1. When we want to run PyTests, there is a simple command, PyTest tests, and it will run our tests. And that's how we know we've got all the files down from the repository and that we're able to start running. We should expect a failing test. This is part of the philosophy of test-driven development, is you start with a failing test. And if we look at our files, we're going to see that we have two things. One is a test method here. So we'll just focus on that. So the test method is going to create a temperature converter class, which is the class under test. That's what we are doing when we arrange the test. The next thing is that we're going to take some action, and here we're going to convert 32 to Celsius. And so our result should be equal to 0. If it's not, then the test fails. So what happened to make this test fail is if we go over to our class under test, which is in the conversion folder, you will see that that method has not been implemented. So our test fails simply because we have not implemented any solution. So what I would like to do is sort of give you the structure here, right? Which is the test is an expression of what we've thought about, which is we need a class and we need a method on that class, and that we have an expectation that if we pass in 32, we should get 0 back. So that's a thought process because we know just a little bit about converting these two temperature scales, which is the freezing point of water. So 32 Fahrenheit becomes 0 Celsius. So what I'm going to do is I'm going to arrange my environment a little bit. Let's split this file to the right. So we have two files. I'm going to close my file tree. And now I'm going to make this test pass. So we did a little thinking. We're got a failing test. Then we want to do the next step, which is to make this test pass. So what we're going to find is that Copilot is going to give us some suggestions. The first is it says, okay, you probably want some doc text that explains that this is a convert Fahrenheit to Celsius method. That's a helpful thing, right? But test-driven development says we should find the simplest thing that could make this test pass. And the simplest thing to do to make this test pass is just to return 0. not to do anything fancier than that. And you can see that Copilot is very smart and it gives us a formula. What I want to express is that in the discipline of test-driven development, you don't want to assume anything beyond what you've been given as the test. So the test doesn't tell us anything about a formula, so we want to try and ignore that. What we would like to do is run the test to make sure that that one passed. So every time I go to this line or I go here, we're going to likely get hints that will tell us that the method could be different. So at the bottom here, there's a little Copilot where we can snooze the completions, and that will stop it from trying to do completions for 5 minutes. That can be very helpful, and as I go along, I will show you an example. So what I want to do now is think a little bit about the next test. So what we want to write is a failing test, and we want to write it based on the requirements that we understand. So this is essentially a specification. So this specification here, I'm going to define as convert with 212 Fahrenheit, expect 100 Celsius. Copilot already came up with that format, so I can just hit tab and it will do that. Not only that, but it looks at what we had above and it says, that's a pretty good format for that. So I hit tab and it generates the result. So what I have is a new piece of code that writes a test. I want to think about this. How does my arrangement work? Okay, I make a new class under test. Do I pass it to 12? Yes. Is the result compared against the expected 100? The answer is yes. Okay, now does this test fail? And when I run PyTest, yes, that fails. So that's a pretty good result. We've got a new failing test. Now I'm going to come over and I'm going to try and make that test pass. So in order to make this test pass, what I'm going to do is I'm going to say, if, and you notice it's going to give me lots of instructions here. I don't want to do this. I want it to not be so smart. So I'm going to snooze it for a second. And I'm going to say, if Fahrenheit is equal to 212, then return 100. And that is a much simpler expression of what it is that I want to pass the test. At this point, I can turn the Copilot back on by clicking here. The completions are back on, and I can go to my next completion. So for my next completion, I want to find something different. So let's say test convert with, and the normal body temperature, I just happen to know, is 98.6. So if that normal body temperature comes in at 98.6 Fahrenheit, it should come back as 37 degrees Celsius. Again, the code completion that Copilot put together gives us a really nice result. And then I do my PyTests, and you're going to find that that one test failed. There are other tests that passed, and this just one failed. So what I want to do is I want to make this test pass, and then here I could say else if, instead of Fahrenheit 32, I could say if Fahrenheit is 98.6, and it does a pretty good completion. And now I can save that. So now it's starting to get the hang of what it is that I'm trying to do. This is kind of a truth table. And it's kind of going through a process like this. The next thing I might want to test is another thing that I've thought about is I found that if I test the convert with minus 40, so let's say with minus 40, I expect minus 40. So this actually is where um, the linear scales intersect. And you'll notice that it's filling in a lot of the type ahead here, but it's up to me to make sure that I understand what's going on. So it's a specification of how the function should behave, but also I need to do some verification. And this type of simple format helps me understand the arrange, the act, and the assert. So I can do that. Now, we're going to look at our next test. Again, I'm focusing right here where it says 1 failed, 4 passed. So our previous 4 tests have all passed. And the one that has failed is just the minus 40 that I just added. So again, I can go here and I can make this look like I want it to and save there. And then my PyTests, all 5 pass. So I can go to the next one. And here I want to define a test with something different. Let's say I want to watch out for a divide by 0 error. So I pass in 0 Fahrenheit. I expect negative 17.78. Copilot already kind of knows that that's a good thing to test. So it makes that suggestion. Here, what I might want to put is watch out for division by 0. Okay. And this, we want a failing test. So let's run our tests again. And we say we've got a new failing test. The 5 previous tests all passed. And the one failing test is the expect 0. So it's going to give me another if statement. Here, Fahrenheit is 0. We want 77.8. Actually, that's not exactly right. We want a different value. So let's do our PyTests. And that passed. Okay. Let's try another value. Let's try something that will cause us a problem. Here, I'm going to define a test where we convert with minus. Now, I just happen to know that absolute 0 in Fahrenheit is about 400 and something. So what if we passed it minus 500 F? What would we expect? We wouldn't expect 0. We'd expect an exception. So, so we might get a value error like this. And this type of exception would come back. So if we run this test, it's going to give, it's essentially going to not pass. So we've got our 6 pass, but our 1 failed. So our new one is the failed test. So here we want to add that kind of logic. So if Fahrenheit is less than negative 59.67, then it is less than absolute 0. And here we're going to save it and see if now that tests pass. It does not pass. And the reason is because the messages are different. And in what way are they different? Well, temperature not defined for conversion is not what the message is. So we can come over here and we can say, assert temperature below 0 is not defined. That is the better message. And then we can remove the message after that. And now let's see if we can get our test to pass. And there's our tests passing. Okay, I'm going to do one more, which is the final boundary of absolute 0. So the test convert is going to be here, which is minus 59.67. We don't expect a value of 0. What we would expect is minus, and absolute 0 is 273.15. Okay, so this is actually the correct test, right? But here it's creating an exception. So we don't actually want that. We want the act to result in a result. And then what we want is to assert this. So this was incorrect. So what I hope I'm showing is that Copilot can be wrong in a lot of different ways. You have to be constantly verifying that the specification makes sense. And sometimes you'll put in a couple of hints in here, test for absolute 0. This converts, so you want to make sure that the words that go with the test also make sense. Here, test for a value below 0. And it's very helpful to just tab the selection and let it choose those if you are confident that the value is the correct value. Okay. And let's see what we have here. We have 1 failed test, 7 pass. So again, this is a case where the value is not in our truth table. So we're going to add that into our truth table and save it. And now we verified. So the final step is, how could we refactor this to actually be valid for any arbitrary value of the input? And the answer to that is, now that we have tests, we can add in our function. So it just so happens we know that Fahrenheit equals, and then we have some range of values here. So the choices are going to be given as a formula. So what I want to do is, let's say, maybe do the conversion formula. And the conversion formula would be return something like this. And what I want to do is make sure that I've refactored it into something that formulamatically will give us the right answer. So now I've changed it, I run it, and everything passes. So now I have both the tests that make sure that all of my example specifications match up, and I have a conversion function I know is correct. Okay, thank you.